Hello again, this is the second tutorial in the custom module series which will explain how to generate controls for your new module. Open the init file in your new module directory in the text editor of your choosing. Up at the top we have a bunch of Python imports. These probably cover most of what you would need, but if not you can add your own imports. If you need to import something that is not a standard Python module, you will have to put it in the data directory and then append the data directory to sys.path before you import it. I will show you what I mean in a minute. Now you can give your module a name down here. This command line gets parsed out by the main interface, so replace example with whatever text you want InteractiveROSETTA to display in the Protocols menu. Right underneath it is the module panel, which is the panel class implemented by InteractiveROSETTA. Do not rename it because InteractiveROSETTA expects it to be called module panel. Okay, there are a couple of important variables here that I already set up for you. The first one is self.protocol code. The value of this string is the name of your module directory. In this tutorial case, it would be cool beans. There are also three variables over here that contain the path to the data, images, and help directories respectively. If you had non-standard Python modules that you packaged into your data directory, you would have to do something like this before trying to import them. Of course you have to import sys first before this would work. The next variable is run.message. The value of this string is what will be displayed below the primary sequences when your job is running. Replace this with the text you want displayed down there. This next variable is self.useServer. If your protocol can only be run on a remote server, because it calls regular Rosetta or needs a lot of nodes to run, then set this value to true. Doing so will make the module force the user to have a valid server path specified or it will not run. If this is false, you may still have it send jobs to the server, but if the server is not available it will attempt to run the local version. If you do not have a local protocol, then this variable needs to be true. Now the rest of this init function for module panel contains wxPython code to generate the controls. Do not worry if you have never used wxPython before, it is actually pretty easy to pick up, and Google is your friend for learning how to do what you want to do. It is also useful to explore the wxPython controls by starting an IPython session, importing wx, and exploring the package. You can use the question mark feature to get the prototypes for each of the classes. Anyway, back to the init script. These first couple of labels are standard. This first one is the name of your protocol, so replace this string with your protocol name. This is split up by operating system. Windows gives the least amount of trouble. With Linux, it seems that the text centering feature does not work. I got around this by implementing this resize text control for Unix function. It is in the tools.py script in the main scripts directory, which is already being imported by default in custom modules. The workaround is to give the labels to this function, along with an X offset and the desired width of the label. The function calculates the length of the actual text and positions it in the center of the area you specified. Here, the length of the label is the length of this panel, which is 320 pixels. Mac is even more annoying. For some reason Mac does not actually listen to you when you tell it to draw text with a certain font. It always defaults to a fixed size and font family, so to get the text to look the way you want, you need to save the text as an image and use bitmaps instead of labels and bitmap buttons instead of buttons. Place the images for Mac in your images directory. Now then, you should not have to change the help button, just leave it the way it is and put your index.html file in the help directory and it will function appropriately as is. The second label contains a short description of your module. Note that long strings will need to be broken up with new line characters to get the text to display on multiple lines and not run off the length of the panel. Down here is where you place your controls. These are just example controls to show you how to generate common controls. Consult online wxPython documentation for help with this. The best thing to do is figure out what information you need from the user to run your protocol, and then figure out what is the best interface to present to the user to make getting that information easy. You have all used graphical interfaces for a long time, so you should be familiar with the ways you can get information through different controls. Delete the stuff when you are ready to design your module for real. Do not delete this control down here. This is the button that is used to submit your job to the local or remote daemon. You can change the text on this button, but do not change its name. Self.button state should contain the text that is on the submit button. This is needed because there is no label for the submit button on Mac, so you have to save the data in a variable. There are some functions down here. Leave these first few ones alone. This activate function is important. Whenever your module gets the user's focus, this function gets called. Usually it reads selected data from PyMall. There is already code in here to read the current PyMall selections and store selected residues, selected chains, and selected models in these variables right here, so you do not have to change anything to get those data. Just use these lists as you see fit. If there are extra things that should happen on a focus event, specify them at the bottom. The format of the data in selected residues is specified right here. For chains, the format is the model name, then the vertical line character, and then the chain ID letter. For models, it is only the model name, which is usually the name of the PDB file without the .pdb extension. Do not change these three functions. Okay, now here are the example functions. You can delete these later. Usually the controls have event functions. For instance, when a button is pressed, you can tell the button to call a function. For instance, this toggle example callback function is assigned to a button back up here. These functions accept self and a variable that is an event object. The event object is different depending on the type of callback used. I usually just ignore the events, but they need to be in the function definition. This function is what is called when the user decides to cancel their job on the local daemon. You should not need to modify this. Call this function to make your job message active in the sequence viewer and call this function to remove it. This is the callback function for the submit button. Do not remove it. You will need to add some code here because this is only a skeleton. First, it checks to see what state the button is in. If you change the text on your submit button, you will have to modify this string right here. The usual states are the submit state, before the user runs the job, the cancel state while the job is running, and the finalize state after the job has run and we are waiting to see if the user wants to accept the results or not. You will not have cancel or finalize if your job only runs on a remote server. There are also some jobs that do not need a finalize state. You can force the user to accept all output by not ever switching to the finalize state. Anyway, for the submit state, you need to add some code right here. First thing you need to do is check to make sure that the user provided all the data you need to run your module, and that the data they provided is acceptable, as in it will not crash your protocol. So check that here, and if there is a problem, display a message to the user telling them there is a problem and return the function. Once you get to this update message, call all of the input should be valid and ready. If the job runs locally, you may also want to disable some controls if you do not want the user messing with them while the job is running. The protocols menu go button is already programmed to disable during an active protocol, so the user cannot change protocols until they cancel the job or wait for it to finish. Down here is where you change the button to the cancel state, and then start the submit timer. The timer runs this function down here. The timer starts out in stage 1, which is where it writes out the input file. First the timer goes to the sandbox location. This function right here brings the Python interpreter to that hidden folder in the user's home directory, because that folder will contain any PDB files that the user uploaded. You will have to modify this code right here. The input file gets the name of your protocol plus input, so in this case it would be cobeans input. The way I like to do this is make the input file keyworded and tab delimited. So for instance, this job requires a PDB file. Here is its name. If you are sending files over to the server, you need to write the contents of the file into the input file, like I did here. Technically you can format this input file however you like since you will be writing the code to parse it. The one thing that is necessary is this required nodes field. If you are running this protocol on a remote server, this line has to be here. Only replace this number with the number of nodes you require for your job. You can replace required nodes with requested nodes instead. In that case, the server will try to get this amount of nodes, but does not actually need to get that many and will accept fewer nodes. You will also get the parameters files and score function wait file by default. Their format in the input file is specified right here. Okay, this is where the input file gets sent to the server or made available to the local daemon. You should not need to change most of this. This code right here is the default code. It will attempt to send your job to the server that the user currently has specified through that server button on the sequence viewer. Your job will not run on the server they have specified unless it is installed on that server. What you can do instead is install it on your server, make it available to the people that will be running your module, and then uncomment this code, remove the code up here, and specify the HTTP URL for your server. Everything else here stays the same. The code that makes your input file available to the local daemon should already work fine. The stage gets set to 2 after this, unless you want the interface to run multiple daemon jobs locally. You do not need to add extra stages, so the second stage is where it is looking for the output file. Note that if your job is running on a remote server, there is no second stage and the timer is stopped after sending the input to the server. Generating the output file is part of another tutorial. Anyway, when it sees that the output file exists, it will parse the contents of the output file. Since you were responsible for generating the output file, you know how to parse it correctly. I will discuss this progress bar stuff in a later video, since you actually control it with the local daemon. Anyway, after that you have to do something with the output, maybe load structures into PyMall as right here, or load information into some of your controls. Whatever is needed. If something bad happened during your job, this error report file is generated, and if the interface sees that file, it will display the error message and cancel the job. You do not need to alter that. Then the last thing to do is program the finalize button. Remember, it is up here in the submit callback function. The finalize dialog box allows the user to hit yes, no, and cancel. Cancel simply returns the function. No will probably just enable all of the controls again and unload the output from PyMall, or something like that. Accept will do something with your output. Usually this means updating the structure in PyMall. This line right here is the function to call if you want to load a new structure into PyMall. The commented code down here should update PyMall and the sequence viewer with new model data, if your model was already loaded before running the protocol. This function down here should not need to be changed. This enable controls function is convenient for disabling and enabling controls during the protocol. Simply write code to disable the controls like so, and then call this function with enabled set to true for enabling or false for disabling. Anyway, that's about it for generating controls. In the next video I will show you how to write the code for a local daemon job.